Find the breaking height of the wave, hb, in feet. In this problem, we are provided the water depth at the breaking location, d. We are also provided the period of the wave, t. To find the breaking height, hb, we'll multiply the wavelength, L, by the quotient hb over L, where hb represents the breaking height of the wave and L represents the wavelength. We'll first solve for the wavelength, L, by computing L naught. L naught is the wavelength for the wave during deep water conditions and is computed by multiplying the gravitational acceleration constant times the wave period squared, all divided by 2 pi. And L naught computes to 1,479.22 feet. In order to reference the wave tables, we'll compute d divided by L naught. And after plugging in the appropriate variables, d over L naught equals 0.01758. By knowing d over L naught, we can determine d over L, and after that, solve for L. In the wave tables, we'll focus on the values on rows 0.017 and 0.018 in the column d over L naught. Next, we'll use linear interpolation to compute the appropriate value of d over L, which equals 0.05388. Next, to determine the wavelength, L, we'll divide the depth, d, by the quotient d over L, and the wavelength computes to 482.55 feet. Next, to calculate the breaking height, we need to compute the quotient hb over L. For deep water conditions, a wave breaks when the height of the wave divided by the wavelength is at least 1 over pi. In this case, hb over L equals the constant 1 over pi. If the wave is in shallow water conditions or in the transition between deep water and shallow water, the wave will break when the wave height divided by the wavelength exceeds 0.142 hyperbolic tangent of kd. In this case,